Hello everyone, and welcome to this presentation of the paper Clip-Guided GAN Image Generation and Artistic Exploration. My name is Amy Smith, and I'm the principal author for this paper, which was co-authored by my supervisor, Simon Colton. I'm in the first year of my PhD with the IGGI program based at Queen Mary University, London. This is actually my first ever paper and my first conference, so I'm excited to be here. So the main components of the models used for the artistic exploration outlined in the paper are GANs, as well as OpenAI's pre-trained model CLIP. Generative adversarial networks, or GANs, are algorithmic architectures that use two neural networks by pitting one against the other in order to generate new synthetic instances of data that can pass for real data. So in this case, the data images. GANs are currently some of the most effective generative models for image synthesis. CLIP is a neural network that efficiently learns visual concepts from natural language supervision. It can be applied to any visual classification benchmark by providing the names of the visual categories to be recognized. The GANs used in combination with CLIP for this work are Big GAN, Siren, FFT, and DALL-E. This approach employs the CLIP pair of pre-trained models, which both calculate a latent vector encoding for a given input, meaning one part is dedicated to generating the image, and the other part, being CLIP, is responsible for assessing the image's suitability given the contents of the prompt. So a bit about the different GANs used. We have Big GAN, which is designed for class conditional image generation, meaning the generation of images using both a point from the latent space and image class information as input. Siren leverages periodic activation functions for implicit neural representations. FFT uses a version of the TensorFlow library Lucid, which was adapted for PyTorch, which then became Lucent, with the fast Fourier transform, or FFT, parameterizer from Lucent. And OpenAI's DALL-E, a 12 billion parameter version of GPT-3, trained to generate images from text descriptions using a dataset of text-image pairs. So let's take a closer look at what these models can generate. Here are some examples from Big GAN as guided by CLIP. Based on the prompt shown here, the model was able to produce these images. So we have the prompt, a skyline in the style of Mondrian, which is a depiction of a skyline with very painterly qualities. We have the prompt, musicians in purple silhouette. This is reminiscent of an orchestra, and there's even a little music note up here towards the top left of the image. We also have the prompt, architecture is really about well-being. So we can see architectural shapes and forms here in sort of bright and fresh colors. And then we have an example here where the model was given both a text and image prompt designed to encourage the image input to be like a horse. So here we have one of the authors doing some modeling of his own, but obviously he has the elongated neck and a mane here. So for the work, four prompts were chosen for the project. They were designed to not be too abstract, like asking for an eyeball in love or something like that, but also not too mundane, like an apple on a table. They were also designed to probe the model's capacity to produce images appropriate to the theme for the work, which was holographic. Each model was used with each prompt, producing 3 images for each prompt from each model. So this produced a batch of 48 output images. Out of the 48, only 3 were unusable. So after removing these, we were left with a pool of artistic images from which the 4-part exhibition series called the Holograph Series was curated. Before we get to show the series, let's look at some samples taken from the pool for each model for each prompt. So we'll look at the models separately at first, and I'll linger on each slide for a little bit so you can just have a chance to look at the images, and then we'll talk about their qualities. So here's an example from each prompt from using CLIP and as guided, Big GAN as guided by CLIP. And then we have Siren guided by CLIP. FFT guided by clip. And DALL-E. And then we just have them here so we can compare them. But it's clear that all of the models are able to innovate visual content based on the given prompts, which is important when considering the artistic value of the outputs. There's also an impressive degree of diversity in how each model interprets the prompts. And this is crucial for producing novel combinations of visual ideas, as the diversity opens up the possibility space, broadening the scope for the visual solutions for depicting the contents of the prompts. The clip and FFT model yielded the least visually diverse results in terms of color, shape, and texture, whilst clip and big GAN produced very visually diverse results that nevertheless adhered well to the specifications of the prompt. Clip and DALL-E was close behind, with arguably the most interesting depiction of color. Both clip and Siren and clip and FFT produce very distinct visual styles that show consistently throughout the results. Clip and FFT produces uniform, centralized compositions that are highly textured, kinetic, and desaturated, whereas clip and Siren contrast this with high levels of saturation, varying amounts of background texture, and more fully formed compositional elements, namely a dragon head, skull shapes, including eye sockets and crosses. So here's the final series. 4 images specifically were chosen for the series, as each image represents a different prompt used. These final images for the series were chosen based on how well each captured the theme holographic, in combination with the subject matter given in each prompt, and how well they fitted visually with one another. Note that no image from the FFT model was used in the series due to the aspect ratio of the outputs differing substantially to the output from the other models, and the dissonance that occurred between the visual styles of each model, as the FFT images were very noisy and monochromatic. So in summary, we found that the clip-guided GAN text-to-image generation produces images which are routinely appropriate to the prompt, usually have artistic value, are often innovative internally, and have high diversity across the population for the same prompt. Moreover, the Colab notebooks are highly accessible, as they require no technical background, and hence could rapidly influence mainstream art production, given the evidence of valuable usage presented here. Thank you everyone for listening, and here's just some contact details for the authors.
Thank you very much, Amy. I have to say that I like a lot both your headset and also your images. They are very nice. Let's see if is there any question for Amy? I don't see. Well, is your system? Yes, very cool. Yes. There is a question by Bill. Bill, do you want to ask by yourself?
Yeah, I was just wondering, the 4 final images you present, are they typical of what the machine can generate, or did you have to search through many to find them? In other words, how much manual effort is required to actually use the system, or is it entirely automatic?
Yeah, so the notebooks are very easy to use. So we'll start with that. They're Google Colab notebooks, if you're familiar with that. You basically just write your prompt into the notebook and run all the cells, and the images are produced, which is how this was done. In terms of how many of the images were unusable out of the batch of the 48 which were produced, which was just all of the output altogether, only 3 were removed because they weren't usable. So in terms of the curation coefficient, it was very, very high because only 3 were removed from the batch that were produced. So I would say that these images are typical from the batch that were produced. And obviously, if I go back here, these are just some more examples from that batch of output. So you can get an idea of kind of the scope of it from here a bit more. Does that answer your question?
Thank you.
Thank you.
Okay, thank you very much, Amy. I'm afraid we should move to the next presentation.